Today's lesson is from Module 7, Lesson 7.1. It's on angles of polygons. And let's jump right in. And first is to hear the definition of a polygon. This is from much earlier in the course. Polygon is a closed figure. And so think of any shape with a side as a polygon. So we've been dealing a lot with triangles. That is a type of polygon. We have many others. Here is the full list of polygons the book assumes you know. Now, the key emphasis on all of these are the first few letters called the prefix. And so like tri means 3, quad 4, penta 5, hex 6, hept 7, oct 8, non 9, deca 10, and dodeca 12. For anything that's not listed, like if it was 17 sides, you would just call it a 17-gon. Or if it was 22 sides, you would call it 22-gon. If it was 64 sides, you'd call it a 64-gon. So as you're doing assignments, the book is going to use these words. It just assumes you already have these memorized. If you want to pause the video now and put these down in your notes, feel free. And so let's introduce this theorem called the polygon angle sum theorem. And so I'm going to count the sides. So this is a triangle, it has 3 sides. This has 4 sides. I'm going to call it a quadrilateral, but it looks like a rectangle. This has 5 sides. It's a pentagon. We already have learned that a triangle has 180 degrees. If this was a rectangle, we would know all of the corners are 90. And we would add those up and we would get 4 90s make 360. And I will now tell you that any convex, quadrilateral is going to truly equal 360 degrees. And then here we have a regular pentagon, and I'll come back to that word regular later. But if you see a pattern emerging, this, increases by 1 every time. This increases by 180. Now, you could notice this doubles, and so both guesses here would be good, 540 and 720. 540 is correct. If I want to quickly explain why, if I was to draw a diagonal in, I want to draw all diagonals without them crisscrossing. So the other diagonal I could draw on would be here. It would crisscross. If I go to this one, I draw a diagonal in. And I want to draw any other diagonals I can without crisscrossing. I can draw this diagonal in. Any other diagonals I could draw would crisscross. So I don't want to crisscross. So all diagonals without crisscrossing. Split this one into 2 triangles, 180 plus 180, 360. This one into 3 triangles, 180, 180, and 180, 540. So if I asked you how many degrees in a 7-sided thing, you would just keep adding 180, 180, 180, or we have a formula. Now, it's best when you're writing your notes to name it like this, because in the top in the red there, I forgot the word sum. I apologize. This should be the word sum should be here. All right. And the formula is this one right here, n minus 2 times 180. That is the sum. Sum is the total using addition. So if I was to add up all of the angles, I would get the total that get it from this equation. And so in this instance, it's 5 minus 2 because the side has 5 sides, or the shape here on the right has 5 sides, times 180, which is 3 times 180, which is 540. Again, if I'm going too fast, please pause, take notes, write these things down. All right. So now we have a 14-gon. Now, when I read this question, it's very important. I see the word sum. I want to highlight that better. All right. I see the word sum. So find the sum. That means total. So total just means I do 14 minus 2 times 180. Right. It's 12 times 180, which is 2160. Right. For a 14-gon. For a 40-gon, I'm going to grab a calculator because I need a calculator to help me. Oh, sorry. I'm doing math in my head. 40 minus 2 times 180 is 38 times 180. So I'm going to grab my calculator here beside me. I'm going to type in 38 times 180. I get 6,840 degrees total. Now, how many angles in a polygon? If you said 40, you're correct. It's got 40 sides, it has 40 angles. Is each one that? No, that's the total degrees. How many angles in a 14-gon? 14. It's total degrees. And so this is how we find total degrees. Before we talk about finding individual angles, there's a very important vocabulary word we're going to use for the rest of the year. And the word is regular. Regular means all sides and angles are congruent. And remember, if you're writing this out, this symbol right here is the symbol for congruent. So all sides and angles are congruent. So both of these shapes in the picture on the left and the picture on the right, are hexagons. If I mark this one on the left, so all 6 sides are equal, and then I also mark these little marks that mean the angles are congruent. And so I have sides and angles congruent. That makes this one on the left regular. All of the sides and all of the angles are congruent. Hopefully over here on the right, you can tell. I mean, looks can be deceiving, but it's hard to be that deceiving. Very obviously, the sides are not all the same. Even more, maybe obviously, the angles are not all the same. And so this one over here is irregular. Example 1b, find the measure of each. Does it use the word sum anywhere? No, it wants each interior angle of a regular heptagon. Regular means all the same. Heptagon means 7 sides. So first, to do one angle, I need to know what is the total. So I still have to do the 7 minus 2 times 180. I have to start that way, even though I'm doing one angle. I'm going to do 5 times 180. I'm going to grab my calculator, type that in. I get that it's 900 degrees. Now that's the total. So to find one angle, I have to take that 900 degrees total. Now it's regular, so they're all the same. So I just divide it by how many there are. In this case, there's 7. I get 128.57. So each of the angles, now I rounded there, but it's about 128.57, or usually the book will tell you to round to the nearest tenth on an angle, so 128.6. Now, in this one over here, is it regular? It's a pentagon, 1, 2, 3, 4, 5, but is it regular? It doesn't use the word regular. And in fact, here, 2x and 3x plus 14, they're never going to be the same. So it's not regular. Now, it's still a pentagon, and so I can still do 5 minus 2 times 180 is 3 times 180 is 540 total degrees. But to find each angle, I first have to figure out what the heck x is. I'm going to add them all up. 142 plus 2x plus 3x plus 14 plus 3x plus 14 plus 2x equals 540. Okay. Again, if it feels like I do any of these problems too fast, please pause the video. I'm trying not to take up 20 minutes on a video, so please feel free to pause and write down things as you need to. First, I'm going to add up just the x's. So 2, 3 make 5, 3 again makes 8, 2 again makes 10, so 10x. Then I'm going to add up just the numbers. 142 and 14 make 156, and 14 again makes 170. Equals that 540. Now to solve this, I need to minus 170. I got to do the opposite. So get x by itself. There's a 10 with it. First, I got rid of what I call the attachment. The opposite of plus is minus, so I minus 170 to both sides. And so over here, I have just 10x Over here, I get 370. Now to get x by itself, I got to get rid of the 10. That's multiply right now, so the opposite is the divide. I divide both sides by 10, and I get x equals 37. Now, as is typical in geometry, I have to ask, am I done? I've done a lot of good algebra, a lot of good math. But this particular problem is asking for the measure of each angle. So I'm not done. To find each angle, well, let's first make a list. There is the measure of angle J. There is going to be the measure of angle H. Now, I know H is the same as K because they're both 2x. There's going to be the measure of angle M, and there's going to be the measure of angle L. And so J is obvious. It's right here. It's 142 degrees. So J is 142. H it says right here is 2x. Remember the x is 37. So that makes H 2 times 37, 74. Well, K is the same as H because they're both 2x, so it's also 74. M is down here. It is this weird 3x plus 14. And so I have to do 3 times x, which is 37, plus 14. I take my calculator. 3 times 37 is 111, plus 14 is 125. And that makes L, because they're the same, also 125. Where is angle? This is asking about angle ABC. Find the measure of angle ABC. Where is angle ABC? ABC is right here. The middle letter matters. So B is the vertex. ABC is at B. So it's one angle of the living room. Well, what kind of shape is the living room? 1, 2, 3, 4, 5, 6, and they all have these pink marks. And again, those pink marks mean they're congruent. So it is not just a six-sided thing. It's a regular six-sided thing, which means it's a regular hexagon. So total degrees, 6 minus 2 times 180. 4 times 180. Total degrees, 720. Total degrees inside the living room. ABC is just one angle, though, and it's a regular. They're all the same. And so I do 720 divided by 6 is 120. And then I write my answer out. The measure of angle ABC is 120 degrees. Again, this one here, make sure you get this in your notes. In fact, to try to help you out, I'll write out what I would write if it was my notes. So the polygon exterior angle, that's an angle sign, sum, and I'll abbreviate theorem. All right, is that the exterior angles, all of the exterior angles equal 360. Again, that's the total. It's not each one. The total of all of them combined is 360. Now, that doesn't matter the shape. If it's 5 sides, if it's 6 sides, if it's 8 sides, if it's 10 sides, the exterior, the ones on the outside, not the inside, but the outside, always add up to 360. The individual angles are going to be different, but the total is going to be 360. If I was to explain this very quickly, I would say that I could inscribe any shape. Basically, think if I pull these strings, I would make the shape disappear, and I would have just a circle. All right, a circle is 360, and so that's why the total is 360. If you need that explained, I can go over. Some people like to understand the why, but knowing that it's equal to 360 is the important part. So what is the shape here? It has 4 sides. What is the name of this shape? Yep, it's a quadrilateral. But I'm not talking about the inside because all the x's and numbers are on the outside. So how many degrees on the outside? 360. Doesn't matter. There's 360. Now, this is irregular, so I can't just divide. I have to add them all up. Just like I did on the inside, except for now I'm talking about the outside. But on the outside, it always equals 360. 6 plus 2 is 8, so 6x plus 2x is 8x. 8x plus 9x is 17x. I have some time here, or room here, I should say, so I'll show my work. I'm going to minus 139 to both sides. And so I get 17x equals 221. And then I'm going to divide both sides by 17. And so that gives me x equals 13. Now, it's geometry, so I have to ask, am I done? The question asks you for x. So you don't have to plug back in because it only asked you for x. And so, yes, you're done. Last example. Again, this is asking about each, so I know I'm going to have to divide it up. It's asking for exterior, so I know I'm using 360. It's using regular, so I know they're all congruent. And it's dodecagon, which means 12. Now, exterior, 360. They're all the same, so I just divide by how many there are. There's 12, and each one is 30. Anytime the shape is regular, the math is a little bit easier. In your workbook for volume 2, page 409, let's do 1 through 3 all. Now, those ones are going to have the most work. Then number 5 and 16 through 24 even. I am asking you show me work. If you do it in the workbook, make sure you have enough space. The workbook does not always have space to write in. And so feel free to do it on a separate sheet of paper and submit it in Schoology to me.